You're on the highway 3 hours into the drive home. The same road you drove this morning, the same exits, the same gray stretch of farmland rolling past the window. And yet somehow the trip back is taking less time. It isn't. The distance is identical. The speed limit is identical. Your car hasn't changed, but the sensation is real and it has a name. Your brain isn't measuring miles, it's counting surprises. This is the return trip effect, and almost everyone has lived it. You drive somewhere unfamiliar, and the journey out stretches into an odyssey. The return trip seems to fold in on itself, arriving before you're ready to be done with it. Researchers in time perception have studied this exact experience, and it shows up reliably in the lab. When people are asked to estimate the duration of 2 equal journeys, one outward and one back, they consistently judge the outward one as longer. Sometimes the difference is dramatic. The puzzle is not whether you feel it. The puzzle is why the same road, the same car, and the same driver produce 2 different lengths of time. The obvious answers fail one by one. Fatigue should make the return trip drag, not vanish. Boredom should stretch each minute into something heavier, the way a watched clock does. You already know the route now, so there are no landmarks to distract you, and distraction is usually what makes time pass quickly. None of that happens. The return trip compresses anyway. So what changed between the morning and the afternoon? Not the road. The road is exactly the same. The thing that changed is you. You carry a memory of the route, and that memory changes how you experience the distance. Time perception runs on memory. When you ask yourself how long a journey took, you don't replay a stopwatch. You estimate from the material your brain stored along the way. The outward trip is dense with new information. An unusual bridge, a town you've never seen, a curve in the highway that catches you off guard. Every one of those moments gets encoded into memory. The return trip has almost nothing left to encode because your brain has already built a file for every mile of that road. When you later reconstruct the 2 journeys, one is a thick book and the other is a pamphlet. The book feels longer. The math of memory becomes the math of time. This points at something uncomfortable. Your sense of how long an experience lasted is not a clock reading. It's an inventory. The more your brain records, the longer the interval feels in hindsight, regardless of what a stopwatch would say. That is why the first time you do almost anything feels enormous. Your first day at a new job is a lifetime of sensation. Your 1000th day at that job is a blur that fits into a single sentence. The input from the world hasn't shrunk. Your brain simply already knows what to expect, so it stops taking notes. Whole stretches of familiar activity get filed away as one repetitive entry, and repetitive entries collapse time. Here is the twist. Novelty doesn't only stretch time in memory. It also stretches time in the moment, and this is where the story gets strange. Psychologists call it the oddball effect. Show someone a stream of nearly identical images, with one rare odd image slipped into the sequence, then ask how long each image stayed on screen. The odd one is consistently judged as lasting longer than the others, even when every image had exactly the same duration. An unexpected event dilates the present. A familiar one slides by without leaving a mark. And this is not a trick of attention. The effect holds even when the viewer senses the oddball coming. So now there's a contradiction sitting on the highway in front of you. If novelty stretches time in the moment, then the outward trip should feel longer second by second, and in a way it does. But the return trip should also feel longer, because nothing surprises you on the way back and you're simply waiting to arrive. That's not what happens. The return trip feels shorter, not longer. How can novelty stretch a single moment but compress an entire journey? The answer lives in the way your brain predicts the world before it arrives. Your brain is a prediction machine. At every instant, it is generating a guess about what comes next. The next word in this sentence, the next shadow at the edge of your vision, the next curve in the road. When the guess matches reality, processing is cheap. The brain confirms the prediction, files the event away, and moves on, and the subjective experience is that time flowed quickly. When reality violates the guess, the brain has to do real work. It flags the error, allocates attention, and writes a memory. That extra processing is what you feel as time stretching. Surprise is expensive, and the brain pays for it in experienced duration. Why would the brain bother predicting the road at all? Because prediction is the only way it can react fast enough to survive, and the same machinery that keeps you alive also edits your sense of time. Hold that thought and look at the two drives again. On the outward trip, every bend in the road is a prediction error. The brain doesn't know what's around the corner, so it processes each mile in full, and time feels long both in the moment and in memory afterward. On the return trip, the brain has a model of the road. It knows the bend is coming, the bridge, the town, the exact angle of the highway sign. The predictions come true one after another, and each confirmation is processed so cheaply that time seems to collapse. The return trip feels shorter for the same reason a movie you've already seen feels shorter than the first time you watched it. The plot hasn't changed. You just know what happens next, so your brain stops paying attention. So what does this mean for your life? If novelty is what stretches time, then you should be able to stretch your days by deliberately adding surprise. Take a new route to work. Eat at an unfamiliar restaurant. Break your routine on purpose, and your week should feel fuller, longer, more dense. The research suggests this works in a qualified way. A week of new experiences is remembered as longer than a week of identical ones, and the memories themselves are richer and easier to retrieve. But there is a catch, and the catch is the oddball effect itself. The oddball effect only works because the oddball is rare. It is the exception against a background of sameness. Show one odd image in a stream of familiar ones, and time stretches around it. Show 20 odd images in a row, and your brain recalibrates. The novelty dissolves into a new expectation, and the surprise is gone. This is why a person who travels constantly can still feel that life rushes by. Surprise is a contrast effect. It lives in the gap between what you expected and what you got. If everything is surprising, nothing is. The familiar is not the enemy of time. It is the canvas that makes surprise visible, the baseline your brain needs in order to notice anything at all. There is a deeper split hiding in all of this, between experienced time and remembered time. A holiday can feel as if it vanished in a flash, and still leave you with an enormous collection of memories. The two measures disagree because they run on different rules. Experienced time is stretched by attention and surprise, moment to moment. Remembered time is stretched by the number of files your brain saved. The return trip effect only looks like a contradiction if you forget this difference. The outward journey felt long in the moment because of novelty, and long in memory for the same reason. The return trip felt short in the moment because of prediction, and short in memory because there was nothing new to save. One journey, two time scales, both running on the same fuel: surprise. That means the return trip is not a glitch in your brain. It's a demonstration of your brain working exactly as designed. Compression is its default mode for anything it already knows. The commute that took forever on your first week barely registers after a year. Your brain has optimized the route, and optimized time feels like no time at all. This is efficient. It is also quietly strange because the same compression applies to weeks, months, and eventually years. A life made entirely of routine is a life with very few files left to read back. The blur you feel when you try to recall last March may share a cause with a highway that felt too short. Both are the feeling of a brain that found nothing new to write down. So the next time you catch yourself thinking the drive home was faster than the drive out, stop and correct yourself. The drive isn't shorter. The distance hasn't changed. Your brain simply knows the road, and knowledge compresses time. You were never counting miles. You were counting surprises, and the return trip had fewer of them waiting. The outward journey is the one that counts, because every unfamiliar mile is another file being written, another stretched second, another memory you'll be able to open later. We spend a lot of energy trying to speed up the dull parts of life. The return trip effect suggests the opposite move. Don't compress the route home. That's already done for you. Go find a road your brain hasn't met yet, and let the trip out last as long as it wants.